So I'm going to work on a couple of videos right here for you. The first video is going to be, well, both of these videos are actually related to the auxiliary view module, module 5. The first video that I'm going to do is going to be from the sketching exercise sheet. So I'm going to do one example of an auxiliary view sketched, and then I'm going to do that same drawing in AutoCAD. So and that'll be the second video. So the first video is going to be related to one of your homework assignments. The second video is not going to be one of your homework assignments, but I'm going to use it to demonstrate some of the techniques that you'll need to create an auxiliary view in AutoCAD. Okay, so let's get started with the sketch. So this is the sketching assignment in Module 5, Auxiliary Views. And what I'm going to do is I'm going to do this auxiliary view sketch and kind of walk you through that. And also, again, just reiterate some of the techniques that that you'll need to use for sketching. So let's go through this. So right here, we can see the auxiliary view location where the auxiliary view is going to be placed. This is a primary auxiliary view, right? Because it's going to be projected from a principal view, right? This is a front view. Here's a top view. And then this will be a primary auxiliary view because we're projecting it from the front view. These little projection planes, this is called a projection plane, and this is a F means front view. So on this side of the projection plane is the front view. The H is it's not top view. When you're using these little projection plane things, the H stands for horizontal plane. So frontal plane, horizontal plane, and then auxiliary plane. We don't really use this in the intro to drafting class, or really in engineering drawing. This is more of descriptive geometry. It's a carryover from that, but we can use it to help locate where the auxiliary view is going to start. So as I said, we're projecting. We're creating a primary view of this inclined surface right here. So essentially what we're doing is we're looking down on this plane. And in the top view, you can see what that plane looks like. Actually, if I cover up this bit, that is the plane, okay? That this part right here is this area right here. You can clearly see that it projects right there, right? So hopefully by now you're starting to understand how surfaces and edges project. So this is the edge view of this surface, and we can see the planar view of this surface. This surface is shown true shape and size. Now, how do we know its true shape and size? Because it is projected through a projection plane that is parallel to the surface, right? So here's the surface in question. Here's the projection plane, and so therefore this is a true shape and size surface, all right? This surface, or this view of the inclined surface, is not true shape and size. How do we know that? Because this inclined surface right here is being projected through a projection plane that is not parallel to the surface. Okay? So parallel to the surface, not parallel to the surface. And so therefore we call this projection of the inclined surface, in this case, foreshortened, right? Because basically it's scrunched in this direction. It's squished this way, right? So normally it's this long, but because we're projecting it up like this, it's this long. But that being said, the general outline or shape of the object is still going to be the same, right? So let's start with the sketching here. Okay, so this is going to be a partial auxiliary view because we're only going to draw this surface, the inclined surface. We're not going to draw any of the other surfaces here, any hidden lines or anything like that. So So this edge right there is that, which is this line right here. It's starting, this edge is one grid box, one square off of the projection point. So I want to start it right there. So I'm going to put a construction weight line there. I'll put a construction weight line here. And then the total depth of this object, or this plane I should say, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So from here I want to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So right there. Okay. So it goes down as far as this edge right there. And now we just start counting. Okay. So you can see this shape right here, this little, I don't know what extension or whatever. It's going to be down on this side, right? So if you're trying to imagine how this is oriented, this view is going to be placed right here. See how that goes right there? So this back feature right here is going to be right there. And it is too wide. Dimensions in this direction are not scaled. Dimensions in this direction are scaled. So I'm going to put an X through that. Okay. So we can count in this direction. So we can count in this direction. So this is 2. So 2. Now, where do we find this edge? Right there. Project it through, and it's that hidden line right there, which makes sense. This edge would be hidden in the front view. And it is too wide also. So we're going to project this right there. And then it's going to be 2. And then we're going to come back down here. And then this is going to go up to this edge. Is kind of in between. I'll try to draw that right there. It's too wide again. Right? And then this comes out like that. Okay. Now, it might, again, because I'm using construction weight lines, it might be hard for you to see, but when I draw the visible lines, you should be able to see it a little bit better. I'll use the same pencil because I sharpened all my pencils, and so, it's going to have to get dull. So, so here's my back surface right here, and I want to use the pole. Right. Here is that. Actually, that goes all the way down through there. This one cuts short. And then we can draw this there. And then let's okay. So there we go. Now I shouldn't be going over these really, but I feel like to help you see them a little bit better, I'll go over them. You probably should not go over them because it really only messes things up. And there we go. Okay. So there is the auxiliary view of this surface. And you can see, comparing this foreshortened view to this true shape and size view, that it is in fact elongated compared to this. This is shorter. This is elongated relative to that. This, as I said, is true shape and size. It's not scaled. How do we know? Well, it's projected through a projection plane that is parallel to the surface. Okay. So, so that's one of the sketches on this sheet. And now what I'm going to do is I'm going to recreate this in AutoCAD in the next video. All right, so I'll see you in the next video.